So good morning, everybody. I'm Marjorie
Good morning.
Kaplan.
Good morning.
I'm co-director of the New Jersey Climate Change Resource Center, and I want to welcome everyone to our NJADAPT training. I'm going to ask folks to mute themselves if you are not speaking. That would be very helpful. So just really quickly, our center was created by statute in 2020 with a mandate to conduct research with application to New Jersey's most pressing climate-related challenges, to create planning tools and guidance, conduct pilot projects, and connect actionable research and information to many stakeholders. And our Rutgers team today includes myself, the NJADAPT project manager, Lucas Markson, who's the associate director of the New Jersey Ag Experiment Station Office of Research Analytics, Professor Richard Lathrop, the director of the Rutgers Center for Remote Sensing and Spatial Analysis, Dr. James Shope, an applied climatologist with our resource center, Michelle Stewart, the web application developer from the Office of Research Analytics, Pritbal Bamra and Jennifer Fogliano, both senior research specialists with the Climate Change Resource Center, Vanessa Tropiano, a senior research specialist with the Environmental Analysis and Communications Group at the Blaustein School, Matt Drews, our digital media specialist, and Maura Sweeter, a graduate student from the Blaustein School of Planning and Public Policy. So here's our agenda for the day. In the next hour, Lucas is going to be giving you an overview of our tools. We'll then take a quick break and then come back for an interactive exercise where each of you will work with the tools through a self-directed exercise. We'll have a quick wrap up and next steps at the end. Continuing ed credits, as you see here, are available and we'll be issuing certificates to those who complete the training. I'd like to remind you again to mute yourself while Lucas is presenting, and during the presentation of each tool, if you have questions, please use the chat box and members of our team will respond to your questions as they come in. We'll also have a few minutes during each segment of Lucas's presentation to answer questions. Now I'd like to get us started. Let's see, I have to stop sharing. And Lucas, take it away.
Sure, thanks, Marjorie. Let me share my screen. Great, minimize this. Good morning, everyone. So I'm going to be giving you guys a walkthrough today of the different tools we have available through our NJADAPT platform. You can reach all the tools through the Climate Change Resource Center's website here for under our research area, under our resources. I'm sorry, under our tool section for NJADAPT. You'll see you can access all the tools from here. The ones we're going to be covering today are NJ Flood Mapper, which is our flood exposure mapping tool, our Municipal Snapshots, which provide climate risk summaries by municipality, our NJ Forest Adapt Management tool as well. And then we're also going to be showing you a new tool that's been just released called NJADAPT, which is specific for looking at hazard mitigation planning data. So we're going to jump right in. We have a lot to cover today. So we're going to start with NJ Flood Mapper. So as I said, NJ Flood Mapper is our visualization tool for looking at the potential flood impacts from both current day and future flooding scenarios against different types of demographic and resources across the state, the coastal region and inland. So I'm going to give you kind of an overview of the tool today, where some of the different data sets are, where some of the different features and functionality are, so you can kind of learn how to use the tool and then use that to kind of explore on your own and get a better handle on how to use it in your day-to-day use. So just to give you a quick overview, so in the top left here, we do have a little menu button. From this section here, you can return to this map here, or you can also access our map services, which provide access to all the data sets that are currently in the tool and allow you to bring them into a desktop GIS platform if that's something that you choose to use. We also have a link to data sources. So this provides information on every single data set that's currently being utilized in the tool. It gives a description of that data set, links to the map services, as well as the authoritative source for that data set, and basically a quick little blurb about why that data set's important. So if you have any questions about a specific data set, you're not sure where it came from, or you want to learn more about it, that's where you would go to kind of get that information. We have our basic map control tools here in the top left. We have a home button, which will return you to that full New Jersey extent of your map, the plus and minus button for zooming in and zooming out, and we have a little compass button to reset your orientation in case you kind of orient the map differently. On the top right here, we have a search tool. This allows you to find a specific place that you may be interested in. So we could type in, say, Atlantic City, New Jersey, and you can click on that, and it will automatically bring you to that location on the map. We also have a small tour button here, which gives you little pop-ups. It kind of walks you through what each of the different sections of the tool have. So that's something that you can always reference to in the future. If if someone else is new using the tool that you're referring it to, they can use that to learn more about it. And we also have a report a problem button here. So if you're using the tool and you find something that doesn't seem to be working properly, or you have a question about why something's a certain way, you can actually use this form here to contact us, provide us with your name and email address, your comment. You can even upload a picture if there's something that doesn't seem to be drawing properly in the map or something like that. So you can send it to us and we can then respond to it and address it. So the main controls for the application are here on your left-hand side. I'll just go over the buttons quickly and then we'll go in more depth into some of them. We have our total water levels tool, which I'll discuss in depth in a little bit. We have our flood hazards layer. So this basically is where we find all of our flooding data. I'm just going to add one to the map right now, just so we have something on the map. Map layers, this is where we'll find all the additional data that's not related to flood hazards. This is where you'd find anything on like infrastructure, facilities, different environmental layers, as well as some demographic layers. We also have a link to New Jersey MyCoast data. This is an external data set that was created. It's crowd-funded data and provides information on specific flooding events and pictures that were taken by the public of those flooding events. And so you can actually add those to the map and view them as well. So I'll show you those later as well. We have a link to our municipal snapshots, which is one of the tools we'll be covering later in the training. We also have the ability to change your base maps. So you can change here from just a general street view. You can change to an imagery view for satellite imagery to look at, see more aerial imagery of the areas you might be looking at, as well as others such as topographic and others. We also have a save, share, and print feature. This can be useful as you're working with the tool and as you're working as part of a team. You can actually save your current map that you're working on, so you can return to it another time. It'll provide you with a permanent link that you can save and then reopen in a browser, and it'll take you to the map exactly how you were working on it, with the same layers you had loaded on, with the zoom level to wherever you were working on, even transparency levels will all be saved. You also have the ability to print the map, which actually provides a nice little printable version of the map with a legend that you can print out on paper. We also have the ability to generate a map image or a minimal view, which provides you with the ability to basically download a JPEG or take a screenshot that you can easily then embed in a PowerPoint presentation or a report or something of that nature. We also have the ability to add custom layers. I'll cover that a little later. We can actually pull in external GIS data that may not be part of the existing tool. So if you have your own layers within the organization you work for that you'd want to bring in, or if you find another data set available that you think would be interesting to use in the tool, you can add that as well. And then you'll also have the legend button down here, which will automatically update based on whatever data you've currently added to the map. So in this case, you can see we've added 2 feet of sea level rise, and it shows the color coding for the depth as well as low-lying areas. On the right-hand side here is our layer control. This is what allows you to kind of manipulate some of the data as you've added it to the map. You can easily open the legend from here as well. You can remove all the layers you've added. But you'll see here, each layer as we add it will appear here on the right-hand side. You can toggle the layers on and off easily by using the on and off button here. You can remove the layer altogether. And then there's also a transparency slider, which you can use as you add more and more layers to the map to allow you to be able to see data underneath itself. What you'll also notice is if we add in one more layer here, let's add the sandy surge extent. When you have 2 layers on top of each other, if you want to change the order, and you'll see now that there's little arrow, up and down arrows here. So you can actually use these to change the order that the layers draw on top of each other. So I can actually put the sea level rise now on top of the sandy surge, and I can change the transparency so I can see the data underneath. And so that's just to show you how you can control those layers. So I'm going to jump into some of the data now and some of the different tools that we have in the application, so you can understand what's there and where you can find it and how you can utilize it. To begin with, I'm going to talk about our total water levels tool. This is one of the kind of key features of our platform. When you open the total water levels tool, you'll see that there's a button up here. This actually allows you to do a walkthrough version of the tool that will kind of walk you through step by step in using the total water levels tool and explain what's going on in each step. Below here are kind of quick buttons where if you've used the tool before, you can quickly jump in, change or alter a setting really quickly, and then update your total water level accordingly. So we're going to open up the main walkthrough tool. So when you first open it up, it gives you a little introduction about the tool itself. It also has a little video here where it explains the concept of total water levels. So when we talk about total water levels, what we're talking about is thinking about in the future both the impacts of sea level rise as well as an additional flood event that may occur on top of that sea level rise in the future. So trying to plan for those types of scenarios going forward. So the video here kind of walks you through that, understanding that process. So then it gets into the actual steps of the tool. So the first step is to select a node tide gauge. So this is to basically give us a location that has some relevance to the area that we're interested in. So you want to pick the area that's closest to the area you might be interested in. It doesn't have to be exact, but as long as it's in the general vicinity, that's what we're using to kind of get our estimates for sea level rise and flooding information. So for our work case today, for our example, since we're already looking at Atlantic City, We'll choose the Atlantic City tide gauge and hit next. So the second step is select an emission scenario. So this is where we're talking about, what do we think is going to happen in the future regarding greenhouse gas emissions? So we have a low, moderate, and high emission scenario. The low emission scenario is basically means we're going to curb greenhouse gas emissions back to certain levels. Moderate emissions means we're going to kind of keep greenhouse gas emissions consistent with our current global policies. And a high emission scenario means we're going to continue to increase the consumption of fossil fuels and greenhouse gas emissions. So depending on the type of thing you're interested in planning for or looking at, you would pick an appropriate scenario. In this case, we'll go with a moderate scenario, just saying we'll at least keep things consistent with the way they are right now. The next step is to select your planning horizon. So depending on what you're specifically looking at, a certain planning horizon will be more or less appropriate. If you're looking at something, say you want to think about something in terms of a 30-year mortgage, you would look at, say, a 30-year time period out, so maybe something in the 2050 time range. If you're looking for something that's kind of a long-term investment or some kind of infrastructure, you may want to be thinking about, as far out as 2100, in certain cases or beyond. So in this case today, we'll just pick something like 2090 as kind of a, somewhere in between scenario. So based on our previous selection, so we selected our location, we selected an emission scenario, and we selected a time horizon. Now the tool is going to give you a custom estimate of sea level rise based on those selections. And you'll see those appear here on the left. And what it gives you is basically some different probabilities of different types of estimates of occurring. So you have a low end estimate, which is basically kind of almost a 95% chance of happening or exceeding. You have what are the likely estimates, which range from an 83% chance to a 17% chance of occurring. And then you also have a very high end estimate, which is kind of like the worst case scenario. And this is something you may use, again, depending on the type of planning you're doing. If you're looking at, say, some kind of hard infrastructure, say an electrical substation, you may need to plan for that worst case scenario high end estimate. Whereas if it's something more like a local park that you're planning, you want to think about the impacts there, you might look at something that's in the more likely range. So for today, we'll just pick let's say we'll go with our 50% chance. We'll pick something right in the middle of the likelihood range. So then your final step is to select your flooding event. You can actually keep it at 0. So you just want to look at the sea level rise estimate that you got from the tool. You can use that. And then we have some of the kind of standard flood events. We have an annual flood, a 2-year flood, a 10-year flood, and a 100-year flood you can choose from. And then we also have historical events you can choose from. So in certain cases, some people may not be familiar with what a 100-year flood might look like in your area. But we can go and look, but Hurricane Sandy, I remember I was there. I know what Hurricane Sandy did to my town or my area. And I remember what the flooding looked like from that event. So I'd want to look at that type of a storm, or say, a Hurricane Gloria or something like that. And so you can actually choose those as well. And you'll see it automatically updates the flood event height here based on the historical event you've selected, or based on the event you select here. So we'll stick with, actually, let me put this back to, we'll stick with a 10-year flood event for now. And then the final screen, it shows a summary of all your selections. You'll see here in the bold price here, it gives you what your actual total water level estimate is. So 6.3 feet in this case. And then it'll basically round it up or down to the nearest foot, since that's what we have mappable data for. So in this case, it's rounding it down to 6 feet. You'll also see things such as your sea level rise estimate based on what we have here. So our sea level rise estimate was 3 feet. And then on the bottom right here, you'll see that you have the add to map. You can click that, and it'll automatically add your total water level to your map. So in this case, we had a 6-foot total water level in Atlantic City. And if we open up the legend over here, we can see that the different color coding shows the different depths of flooding waters in those areas. And so we can actually see what's going to be potentially underwater under that scenario. So we can continue on to some of the other data sets we have. So if we go into the flood hazard, you'll see the total water levels is here as well. You can actually, if you already know the specific total water level you're interested in, you can quickly use the drop down and select whichever one you want. We have data from 0 to 20 feet available. And something else I'll point out too is for each one of these, there is a little detail button here. So if you're not clear what a specific data set is, you can quickly open that to get a brief description of that data set. We have sea level rise data. This comes directly from NOAA, available from 0 to 10 feet that you can add to your data. We also have the sea level rise mapping confidence, which shows the areas where we have high or low confidence in terms of the inundation for those layers. Some new data sets we've added is our what's called HAND. It stands for height above nearest drainage. This is an inland riverine flooding data set. And so we have something similar to the total water levels, where you can add anywhere from 1 to 15 feet of inland flooding. So here, actually, we can show like an example of that here. Let's go inland a little bit. And we'll select, say, we'll do a 6-foot inland flooding data. And so you can see here, basically, it provides riverine inland flooding based on precipitation that occurs from rainfall storm events. And you can add that to your data set as well. In addition to the 1 through 15 levels for that data, we also have ones based on specific historical precipitation events and adjusted for climate change. So if you use this drop down here, this is actually data that's based on, we use historical rainfall data and flooding data from riverine gauges, and we were able to calculate basically an average storm event and a maximum storm event based on historical data for the entire state. And so you can either add that base average storm event or base max storm event. And then we've also calculated for increases in precipitation that could occur due to climate change in the future. So you can look at a base storm event plus 30% extra precipitation or plus 50% extra precipitation, and same for a maximum storm event. We also have the Sandy surge extent data here you can add. We have hurricane surge modeling data for categories 1 through 4 hurricane events that you can add as well. And we have the FEMA flood zone data for the entire set that you can add as well for flood hazards. So that covers all the flood hazard data. Under map layers, you'll see we have a lot of different types of data that you can use to kind of look at the intersections of flood events and flood hazards with different types of infrastructure and resources and populations within your area. You can add the boundaries to the county or municipal boundaries to the map to help understand the areas you may be looking at. You can add, we have infrastructure, which includes things like wastewater treatment plants, energy generation facilities, mobile home parks, power plants, similar things of that nature. Under facilities, we have things such as schools, fire stations, hospitals, law enforcement facilities, nursing homes and assisted care facilities, evacuation shelters, and historic preservation. So we can say add hospitals to our map. You'll see them appear with the little hospital symbol on the map. All the data on here is interactive, so you can click on a specific location and you'll get a little pop-up with all the attribute data for that location. So in this case, we're looking at University Hospital in Atlantic City. In addition to that, we also have transportation data, so the data on hurricane evacuation routes, bridges, rail lines, and gas stations. Environmental hazards include things such as known contaminated sites and EPA cleanup sites, which may be an issue due to flooding that could cause contaminants to enter into some of the waterways. We have some data on marsh and open space. So we have data on where tidal marshes are located, the different open space programs throughout New Jersey. And then we also have data showing marsh retreat based on different levels of sea level rise you can look at in something more the coastal areas of the state, as well as data on marsh edge erosion. Some of the new things we've added is data on social vulnerabilities. We have access to a specific snapshot that was created separate from NJADAPT, but we felt would be useful here, that provides data on disability populations within municipalities. But then we also have data sets from the DEP, from their environmental justice laws, overburdened communities data set you can add. We have data on this CDC Social Vulnerability Index. This provides data both at broken out to specific topic areas of vulnerability, such as like socioeconomic, but we also have the individual census variables that go into calculating those indexes available as well. So you may look at, say, the socioeconomic index, but you can also then look at, say, the specific amount of people below poverty or the percent of people below poverty, and see how that variable plays a part in or role in that index. We also have data from United Way on their ALICE households data set. So ALICE is basically stands for asset limited, income constrained, employed households. This is basically a measure that kind of looks at the working poor in the state. So people who are employed and have income, but they are barely making ends meet and may be specifically vulnerable to different types of flooding events or climate change events. We have data from the US Census on veterans populations. We have the Department of Community Affairs Municipal Revitalization Index distress score to help identify municipalities that are specifically identified as being in distress. Census data on housing built before 1970 that may be specifically at risk from flooding events. And then we have some data on homelessness counts, which is relatively coarse, is that it's collected at a county or multi-county level, but at least can give you some information about how much homeless population may be within a specific region or area. And then we also have land scan data, which comes from Oak Ridge National Laboratory and uses satellite imagery to help understand exactly where people are located based on, I think, heat signatures. We also have some data on property loss. This comes from the National Flood Insurance Program. This is at municipal level, but it's basically aggregated data on the amount of payouts that have been done in terms of buildings and content claims under both the repetitive loss, severe repetitive loss, and the National Flood Insurance Program. So you can add that as information to understand areas that are routinely hit by flood events and have insurance claims because of them. We also have data from land use land cover from New Jersey DEP that you can add to look at the different types of land use that may be impacted by specific flooding events. So you can actually add that, and we can move that down underneath our total water level. And so you could kind of play with the flooding and see which of those types of land uses might be specifically being impacted by that flooding event. And finally, we have our data from our Office of Emergency Management project, which I'll be going over as a separate tool, but you can access all those data sets that are available through that here as well. And so we'll go over those separately when we talk about the other tool. I'll just quickly show you the New Jersey MyCoast. We'll add that to the map. Sometimes it takes, oh, you'll see here, it's a little hard to see. Let me turn some of these others off so you can see it more easily. So you'll see these little wave icons appear. You can actually click on any of the icons. You'll see it pulls actually an image of that image that was crowdsourced and provided to MyCoast. And there's a link here that'll take you to the MyCoast page and see that you can actually see the water report, the weather condition report for that flooding event. The last thing I'll show you is our custom layers. So custom layers, this is a kind of our first attempt to allow you to kind of bring in external data sets into the tool. The way this works is you can basically add any type of data that's available through a mapping service, either through your own internal map services that you may have within your organization, or from publicly shared map services such as those by New Jersey government or from the federal government. So just kind of show an example here. I've actually gone to the New Jersey OpenGIS portal here. I found a data set on legislative districts. This is not something we currently have in the tool right now, but it might be interesting to know, when you're talking, say, with legislator, be able to show them the flood impacts within their specific district. And so if you scroll down on the right-hand side here, you'll see there's these view API resources, and there's one specifically for GeoService. And so what we need to do is basically highlight that link up to, we just don't want to include anything with the query side there. So we just kind of cut it there, copy it, come back to Flood Mapper, paste it in. You can do a check URL to make sure that it's able to find the data properly. So it'll give you the layer name, in this case, legislative district. It tells you the type of data it is and the geometry. And then you can basically add it to the map. And so we'll see here, it's now added our legislative districts to the map. And so you can see the custom layer control here. So it'll actually, as you add custom layers, it'll keep track of them here. So even if you remove it from your layer control, you can come back here and add it back in at any time. But you'll see here, these are, again, are interactive. You can click on them and get information about that specific legislative district. It automatically pulls in the legend from the map service. And so this is a nice way to be able to pull in different types of data sets that maybe we haven't thought of including yet at this point, but maybe you find useful in your use of the tool. So I'm going to stop there and take a quick break. If there are any questions, I haven't been watching the chat as I've been presenting, so if there are any questions that come from the chat that I can respond to, please feel free to bring them up. You can feel free also to unmute yourself if you have a question.
Hey, Lucas, there are a couple questions in the chat that you can maybe answer more quickly than I can as I'm trying to field them. Sure. One of them was the date for the FEMA NFIP data.
I believe it is from, that's a good question. We can probably actually check our data sources page here. If I remember correctly, I believe it may be from this is through 2019, January 2nd of 2019 for the repetitive loss and severe repetitive loss, and the NFIP data looks like it's through the end of 2018. This is something we've had to collect and then aggregate. It's not something that's necessarily freely available, so it's something that takes a little bit of effort to update, but it's something we are working on updating to try and keep current.
Thanks. And then there was a question about the ability to display the flood depths in NAVD 88. And I know that we don't do that right now, but it is something we have talked about in the past. So do you want to say anything about that?
Sure. So I will speak to this as best I can. While the data is provided as in terms of mean high or higher water, the actual flood data that's occurring over land is actually done in NAVD 88, is my understanding. Is that so when they generate those flooding layers, they calculate the flood level at the coast at that mean higher water level, but then it's converted into a NAVD 88 elevation in order to then figure out what land areas and what elevations of land are inundated with that water. We've talked about possibly adding some types of tools to help with conversion between those, but we haven't gotten to that yet.
Thanks. And then there's a couple questions about the adding data, exporting data. Someone asked about the ability to download the shape files. You would go to the map service directly to be able to do that, right?
So yes and no. So the map services allow you to import the data into ArcGIS and then work with the data within your desktop GIS platform. You can't download the shapefiles directly to the map service. This is something we're working on updating. We're working on converting the map services over to an ArcGIS portal interface, which will then actually have a nice, easy access where you can download data sets directly as shapefiles or tabular data as CSVs and Excel files. So that is something that's coming. With the map services, most of them, I believe, once you bring them into ArcGIS, I think in Pro, there is a way to kind of copy a feature and make a local version of it. But right now, there's no way to directly get the shape files from the map service. That's something we are working on.
Thanks. And then Michelle answered the other two questions that were about layers. So thank you, Michelle. And there was one other question. The first question that came in from Jenny, she asked how the FEMA flood zones are defined in relation to all of this. And I kind of generically just said that the FEMA firms are in there. But if Jenny's question was more nuanced, Jenny, I would invite you to explain that in the chat, or if you want to come off mute and tell us, we could answer the question better.
Sure. I just meant, from a newbie's perspective, whether or not they get added. So when you put the FEMA flood zones, what is the baseline? I guess that's what I was asking, if that makes any sense. Like if you add on other stuff, is that potentially already included in the FEMA flood zones?
Oh, so you mean like other flooding events included in the FEMA flood zones, or?
Yeah, exactly. Yeah. Like, does it add for the total water level, or, I was just trying to understand what's already included in the FEMA flood zone to prevent double counting.
Sure. I don't know how well I can answer that question. So the FEMA flood zones, these are directly from FEMA. These are actually a composite of both the effective and the preliminary FEMA flood zones, because there are some that are being revised. My understanding is they are also, there's pretty general understanding that they're kind of old and out of date and need to be updated. So they are here for the purpose that they are still what is legally, what is being legally bounding and what is being used by FEMA. And so you can see them. However, the total water levels and the sea level rise estimates, those are done separately. Those are actually done using specific, modeling techniques. So they are they'll be a little more accurate in terms of the flood areas, where the FEMA flood zones, they may be, like I said, they're based on older data. They may not be the most accurate in some cases, but they can still provide a useful information about historical flooding in areas for identifying those areas. So you can actually look at those. Yeah, you can look at those in combination with the data sets, and you may see some discrepancies in some areas, but it's useful to use both and see, areas that may be impacted by both or only one or the other.
Great, thank you.
Welcome.
And then there's a little more clarification being asked for about the ability to add data. Can you upload a layer as a file from your local computer, or does it have to be hosted?
No, currently it has to be hosted. We don't have the ability to upload shape files yet. One of the things we are working on is also integrating it with arcgis.com. So if you do have an ArcGIS Online account, you can upload data to your ArcGIS Online account and then pull that data in more easily. That's something we've been working on a prototype for in another project. We're working on that. We'll be adding that to NJ Flood Mapper. So right now it's just map services data. With the current state application, we couldn't handle all the potential storage issues with uploading shape files, as well as some security issues, making sure that what's being uploaded is what we expect. So purely map services, but like I said, you can pull them from any ArcGIS Online, arcgis.com. You can find those URLs for the map services and put them in, and it'll be able to handle them and bring them into the tool.
Great, thank you. That's all the questions. Great questions, folks. Thank you for having those. If there's any more about Flood Mapper, you can stick them in the chat. But I think Lucas will now move on to the next tool.
Well, I think we missed one question.
Okay.
Josh DeFlorio asked, any ability to display flood depths in reference to NAVD 88?
So we kind of discussed that. So we can't,
Okay.
It's not, we don't have anything specific in NAVD 88. It's like, so most of the data is provided in mean high water. But the depths, I'd have to go back and check and answer that for you about the total water levels and the sea level rise. I know those, like I said, they use NAVD 88 for to figure out the flooding in those areas. So I'd have to double check what the units are for those for you, but I can't tell you that off the top of my head. I'm sorry. Okay, so let's move on to the next tool. Keep this thing rolling. So right now, I think I'm going to jump to ForestAdapt. We'll change it up a little bit, and then we'll come back to some of the other flooding data sets and tools that we have. So NJ ForestAdapt is a tool we've designed to help understand the different types of climate impacts on the forestry sector in New Jersey and the broader region. So we do have a tutorial you can walk through, but you can also just jump in to start collecting maps. When you first come in, the first thing it does is ask you to select the data theme. We have a lot of different types of data sets in here regarding forestry and different types of climate risks affecting forestry. And so you can change between any of these once you go in, so don't feel like you're bound to one. You can literally, if you want to just get to the map, you can click on any one just to kind of get in. But if you want to start working with a specific data set up front, you can select that from here when you first enter the tool. So we have specific data on climate projections and various factors that would affect forestry. We have some data on climate associated risks for forestry, data on Forestand and carbon characteristics, data on species distribution, as well as future projections of those species distributions, county forest statistics from the U.S. Forest Service's FIA program, different data sets on land use and forest cover that I'll show you, some data on pest and disease risk, and then some data sets on other risks, such as things like fuel, wildfire hazards and fuel hazard maps. One of the data sets we used to have, however, it's been taken down by the federal government, has not been put back up yet, as our damage age range map. This specifically looked at different types of damage from specific types of biological threats to forestry. Once we get those back, they get back up, we'll be adding them back in. So I'm going to jump in. We'll start with species distribution and future projections, just to kind of get into the map here. Once you're in, you'll see we have there's a menu here on the top here that provides you can jump back to the selecting your specific data source if you want. You can also do that from here on the top left. If you click here, you'll see you can jump between the different data categories as you want to. We have a little tips page here that provides you with information that, like, for tips on tree planting that you can click through. We also have, oops, sorry, I just lost my page. I apologize. There we go. We also have a link to resources, which provide you a bunch of information about the climate impacts on different types of tree species throughout the region. Can't see the rest of the stuff. The Zoom is blocking my, there we go. We also have a link for case studies. They'll kind of walk you through how using the tool in different types of contexts. We again have our link to our data sources. You can find all the data information about that's being used in the application, and a link to the map services for all the mapping data that's available here for forestry related stuff. On the right-hand side here, you have some of your basic tools, so you can change your base maps between satellite and light and dark gray and a topographic map. The home will bring you back to this general extent of New Jersey. You can open our legend here as we have data in, you'll see that appear there. And we can also toggle county overlays to help as we start adding some of these large data sets to help keep us situated in terms of where we are in New Jersey. The other thing we'll show you here, it's a little hard, you may not notice it when you first come here, but there's a select location thing, little tool here on the top left. This is where you can select a specific location that you might be interested in. So we can say, select like Burlington County. You'll see it automatically zooms into that county and provides an outline for it. You can also select a municipality, such as, let's see, we can do like Chesterfield Township. And you see it automatically zooms in for there as well. And this is how you access we have snapshots available for the forestry data as well. So we have a municipal forestry snapshot and a forestry climate risk snapshot. So when you click the municipal forestry snapshot, it opens up a new tab with this report. You can download it as a PDF, but basically provide you with some basic forestry statistics for the municipality as well as for the broader county that municipality resides in. So we have some data from the National Land Cover Database, provides information on the total amount of canopy cover within the municipality, the amount of that canopy cover that's within urban land uses within the municipality, and then the total amount of impervious surface within the municipality. And then it gives a breakout further of that. So we've done an analysis to look at the breakout of canopy cover by the different types of urban land uses within each municipality. So you can see how much canopy cover there's in residential versus commercial areas versus mixed use areas. All the graphs here are interactive, as you can see. As you hover over, you can see that data set. There's also a little menu button here where you can export the graphics as image files or download the data that's within the graph to make your own graphs with it, or to, like I said, embed those graphs within reports or presentations. We also have a general just breakout of the urban land use land cover types. You can see how the canopy cover might relate to the total area of that land use. There's also a little mini map here that's embedded in that actually shows you the canopy cover within your municipality. And then we have a breakout using the land use land cover data from DEP of the different types of land use land cover within the municipality, and then a breakout of the different types of upland forest and wetland forest. So you can see kind of how much is deciduous versus coniferous and mixed and shrub within your municipality. And then the bottom half of the report is your county level statistics. So this is where it provides data at the county level. It gives you a little more detailed data that we're able to get from some of the data sets we have available. such as the forest composition. So in this case, we can actually see what types of species groups are prevalent within a county. So we can see in this case, we have loblolly shortleaf pine is the most prevalent within Burlington County, and it gives you the total amount of acreage for that species group. We also have it broken out by forest size class. You can see how many large trees versus medium and small size trees are within the county, and also by forest age class. So you can see how old the tree stock is within a specific county. The second report that we have that can be useful is a forest climate risk snapshot. And so this, again, this looks at specific climate data that may be important when thinking about tree species within your municipality, either in terms of planting new species or the health and longevity of existing species. So we have some data here on growing degree days. We provide the historical baseline of the number of growing degree days and then the projected out for two different climate scenarios. So our moderate scenario, what's called RCP 4.5, and our high greenhouse gas emission scenario in 8.5, and then for two different time periods. And then we provide the average and then the change from the historical to that new projected average. Similarly, we have data for the plant hardiness zone. This is a specific zone that deals with the temperature range within that area, that it can be how cold it basically gets and how warm it gets. It can impact whether certain species may be able to survive in that climate area. Also information on heat zone days, also data on seasonal extreme temperatures, so number of days with a maximum temperature above 95, what the current historical baseline averages and what the expected future projection is under those same different types of scenarios and time periods. Days below minimum of 32 degrees Fahrenheit, which can also be impactful for tree species. And then finally, we have a little infographic here about the projected change in tree species for the entire mid-Atlantic region. And you can look at that more closely and show individual species and which ones are expected to maybe increase or decrease or stay the same based on projected climate change. And then there's links down here for additional resources. So getting back into the actual ForestAdapt tool. So one of the data sets we have here is our species distribution and future projections map. You can select a scenario and then a species group. You'll see here there are little eye buttons. Again, these will bring up little informational windows that give you more detailed information about these data sets. Some of them could be a little complicated, so it's useful to kind of look at these and understand what the data you're actually looking at is, so you can understand both the source of the data and how it's maybe calculated. So we can look at, say, current day, and then you can select the species group. So we have it broken up by conifer, maple, beech, birch, oak, hickory, and others. So we could say look at oak and hickory, and we could then select a specific species. And so this data is a little coarse, but it provides you with let me zoom out a little, our county overlay on. We'll open up our legend. So this basically is it's providing you with an index of the importance of a tree species within an area. So the darker the blue, the more important that species or prevalent that species is within that area. So we can see here for this specific species, we do have some areas in Burlington County that are where the species is more prevalent than others. But then you can also look at, instead of current day, you can project out. So we can look at, say, the year 2100 under a high emission scenario. And how does that change? So we'll see, it takes a couple seconds to load. You can see here we've gone from having some areas in the dark blue to some areas now they're lighter green, meaning that while the tree species will still be in this area, it will most likely be less prevalent due to the changes in climate that's predicted to happen. And if we zoom out, we can actually see is now some of those more important areas have moved kind of further north and west as that climate is projected to change in the future. So you can also look at a delta. So where we talk about is the change. So not just the current prevalence and future prevalence, we can see, okay, well, where are the areas we expect it to decline and areas we expect it to increase? And so same thing here, you can kind of look at that data here, where the pink areas are areas where we expect that species to decline in prevalence, and the dark green areas are areas we expect it to improve. So we can switch to some other data. So our climate data that we have here, we have a broad range of climate data. This all comes from the Northeast Regional Climate Center up in Cornell that we partner with. We have different data sets. Again, you can look at historical data or projected data for a moderate or a high emission scenario. And then you can select a year time period based on, so if we select, say, a high emission scenario, you can look at the change from the current baseline to 3 different time periods in the future, or you can look at the overall value for that variable in the future as well. So right now we're looking at cooling degree days. You can also change by, for certain variables, we do have it on by season. So you can toggle between those as well. Some of the data we have is heating and cooling degree days. These are measures of actually energy usage that occur in order to both cool a resident or heat a resident to a certain temperature, such as like 65 degrees Fahrenheit, based on external temperatures. So when we expect much hotter climate in the future, we expect there to be a greater amount of energy that needs to be used to cool, residences and buildings down to an acceptable temperature. So this can be useful in thinking about energy usage due to climate change. We also have data on growing degree days, which can be specific for different types of plant species. The mean daily maximum temperature. So you can see what the expected average daily temperature, maximum temperature will be for both winter or summer. Same thing with the minimum temperature. Also, average monthly precipitation, days above 95 degrees Fahrenheit, which can be very interesting, especially even beyond forestry, but also looking in terms of public health and thinking about things such as heat exposure. Days and also days below minimum 32 degrees Fahrenheit. Also note here at the bottom, we do have transparency controls for the layer you're looking at, so you can control that as well. And then just to kind of briefly show you some of the other data sets we have under climate associated risks. Like I said, we have data on heat zones. You can look at that, plant hardiness zones. And then also we have data from land surface temperature. So you can look at data for say, 2019 in July daytime temperature, and you actually can see the estimated surface temperature under those types of that time period. We also have some data on Forestand and carbon characteristics. So again, you can select a specific time period for the data. We have two different data sets available, an older one and a more recent one. And then you can look at things such as forest carbon total, the carbon above ground, below ground, understory carbon, standing dead carbon, down dead carbon, and so on and so forth. We also have some county level data on different types of forest statistics. So you can look at specific types of species groups here and then get the information about the forest type, the growing stock removals, the mortality, and the stand age for each of those species at a county level. We have some interesting land use data here. We have data on the percent of the area that has canopy cover. So we have the percent as well as the change available. So you can look at changes in canopy cover at a broad scale, but then the actual canopy cover. We also have data on impervious cover. So that can be useful too to look at impervious areas within municipalities and counties. We have the DEP's land use land cover data set specifically broken out by forestry data. So you can see where specific types of forestry are located throughout the state. And then we also have a continental U.S. forest type group, which basically shows the location of different types of tree species nationally. We also have some data on disease, pest, and risk. So you can actually select a specific pest here or disease, and you can look, it'll give you the percent total basal area loss or the host basal area loss, and you can kind of look between these to see, kind of get an information about the type of damage that's been estimated for those specific types of pests with different types of tree species. And then finally, under other risks, like I said, we do have our USDA plant hardiness zone data. We have our wildfire fuel hazard data set, so you can look at where areas where there's high risk of wildfire. There's also the U.S. Forest Service's land fire data set, which again provides another data set on fuel hazard. And then we also have data on marsh retreat and also on forest dieback zones. So a lot of this data, like I said, unless you're specifically into looking at forestry data, may be kind of beyond some of the scope you might be interested in, but it is a powerful tool with a lot of really interesting data sets on the forestry resources within the state, as well as the projected impacts of climate change on those forestry resources. Similar to our other tools, you do have the ability to save the maps here. So you can, as you work on a map, save it and then retrieve it at a later point in time. And that is basically, I think, all I have to cover with ForestAdapt. I'm happy to answer any questions now regarding this tool for a few minutes before we move on.
I think we're good. Unless somebody has a question, you can raise your hand or unmute yourself.
Okay. Well, if there are any other questions, like so during the activities, we'll be available to answer them. So you can feel free to ask questions then as well. So we'll move on then. Next we'll switch to our Municipal Snapshots tool. So this is, you can access this tool either through our NJADAPT page, or you can access it directly from NJ Flood Mapper. This basically provides you with kind of a nice quick snapshot report of the impacts of flooding on a specific topic area within a municipality across the state. So it's a pretty easy to use interface. You just select your county first that you're interested in. So we can say we were using Atlantic City before, we'll stick with that. You select your municipality, And then you'll see we have 5 different types of snapshot reports you can choose from to view. We have a built infrastructure report, a critical assets report, a natural and working lands report, a public health report, and a vulnerable populations report. And so when you click on these, it provides you with a snapshot report similar to what we looked at with the Forestry ADAPT. You can download these reports as a PDF file. Each report provides an introduction of what the report is about and some of the data sets and explanations of the data sets that are being used within the report. Has a little inset map showing the location you've selected, and so you can see it's kind of where it is in relation to other areas of the state. And then it basically starts pulling in some of the data sets we have in Flood Mapper and providing an analysis of the flood impacts on those data sets for you automatically. So in this case, we're looking at built infrastructure. So it's pulling in those data sets from the built infrastructure section of the tool, such as wastewater treatment plants and energy generation facilities, and also includes bridges and gas stations. And so the first column here shows the total number of those assets within the municipality that we have data for. And then we have information on the number of those that are exposed at 2 feet of total water level and at 7 feet of total water level. As you can see here, the numbers that are being impacted there. And then there's also graphically shown here as a bar chart showing those impacts as well. Again, these are interactive. You can click on any of them. You can also download the images. You'll also see that within the reports are these linked to infrastructure live maps. If you click on those, it'll actually automatically open the map with your municipality, with those flood levels, and with all of those infrastructure or whatever data set is being used within that specific table you're looking at, automatically loaded on the map for you. And so you can automatically bring things up and start clicking on them and getting information and looking at actually visually seeing where those impacts are if you want. We also provided, in addition to the total water level impacts, we have the impacts potentially from FEMA flood zones. So specifically looking at which facilities or infrastructure are within the 1% annual chance flood event, or the 100-year flood event, and the 0.2% annual chance flood event, or the 500-year flood. So same thing, we have that in tabular format, as well as within graphical format, and it's same that you can open a live map to have the FEMA flood data and all those assets. And then we also have some inset maps into the report just to kind of provide some information where those assets are located, and with the FEMA flood zones, the 2 foot of total water level, and the 7 feet of total water level. And we have legend here at the bottom to kind of explain all the different points maybe on the maps. And then we have a little appendix down here which explains the total water level approach, like we discussed with the total water level tool, for those who may not be familiar with it. And then we have metadata and sources for all the data used in that snapshot report. So this is, like I said, it's a great way to kind of get a quick kind of information about the impacts of a specific municipality. In addition, so we also have the critical asset report, which is basically the same format as the built infrastructure, just instead it's using the critical infrastructure such as schools, fire stations, and hospitals and law enforcement, and provides that same exact data that we saw in that previous report. The natural and working lands report is a little different. It has data on specific impacts to natural working lands. So we have data here on specific types of land area that are exposed to flooding, such as wetlands, tidal marsh areas, open space, beaches and dunes, agricultural land, and forestry land, both at the 2 foot and 7 foot total water level, as well as the FEMA flood zone impacts for those areas. We have some area information on marsh erosion, if there is any within the municipality, as well as wetlands retreat based on a 2 feet of sea level rise estimate. As you can see here, the different types of marsh impact in terms of conversion or loss, impacts on public access points, so beaches and other public access points, how many exist within the municipality and how many would be impacted by those types of flood events, both for the total water level as opposed to FEMA. And then we have a map showing those public access points and their impacts within the 3 different types of flooding that we're looking at. The public health report, this is pulling in data from the climate data that we have from the Northeast Regional Climate Center and looking at specific, providing estimates on climate change specifically to that locality. So in this case, we have data on the number of days above 95 degrees Fahrenheit, those cooling degree days, which is that energy usage to keep residences cool, and the max temperature in July. So we provide the baseline, which is based on this historical time period from 1981 to 2010. So we can look here, we see that during that time period, we had roughly 4 or fewer days above 95 degrees Fahrenheit, and the max temperature in July was between 81 and 85 degrees during that time period. And then we have data for a moderate emission scenario and showing the change from that historical to each of these time periods, and a high emission scenario. So we can see that under a moderate emission scenario in 2060, we expect there to be an increase of up to 10 more days above 95 degrees Fahrenheit. We can see the max temperature expected to rise between 3 and 4 degrees under that scenario for that time period. So this can be useful information when thinking about the potential heat impacts within the municipality and thinking about things like cooling centers that may be needed in the future. We also have data on flooding impacts on specific health-related sites, so hospitals, nursing care homes, and then things of environmental that cause environmental harm, such as non-contaminated sites and EPA Superfund sites. They may be impacted by both the FEMA flood zone areas or the total water level areas. We have a link to because vulnerable populations can be specifically impacted in terms of public health. So we have a link to the vulnerable population report, which I'll show next. And then we have the different maps showing, I believe these are showing known contaminated sites and cleanup sites throughout the areas impacted by different flood impacts. The final snapshot that I'll show is our vulnerable populations report. So this is using data from the U.S. Census American Community Survey. It's using the most up-to-date data. I believe it's currently using the 2020 data set. Basically what was done is we actually conducted an analysis just to kind of give you a little background. So when you look at census data, it typically is provided a specific geographic area, such as a census tract or a census block group. The issue with that can sometimes be that in certain parts of the state, some of those block groups or tracts can be quite large and doesn't really show you where the population may actually be located within those blocks or groups. So when you're looking at things such as the impact from flooding, while maybe a third of that census tract may show as being impacted by flooding, you don't know if that's really a third of the population or if that where the majority of the population might actually be located. So what we did was we actually did a quick analysis looking at the land use land cover data provided by DEP and looked at the urban areas within each of the census block groups and census tracts that we have data for, and looked at what the impact of the proportion of impact on the urban area within those tracts were. And so you'll see here, we kind of give a broad overview of that analysis here. We provide the total population, total housing units. We have some total data such as the average municipal household income, the total municipality in terms of acreages, and then the total urban area within that municipality. And then we provide a breakout showing the amount of that urban area that was impacted by 2 feet of total water level. So we have the total acreage in the proportion, and the area impacted by 7 feet and by both of the FEMA flood zones. So these percentages are then what we are using to basically apply to the demographic data to try and get a slightly better estimate of what proportion of that population might be impacted by these different flood events. And so then it works its way into the different categories of that CDC social vulnerability index. So it looks at, say, social economic status is our first category, and it shows both the total population within that variable, within that municipality. So in this case, in Atlantic City, we have 13,999 people that are estimated to be below poverty. We give the percentage of the total population that represents, so 36.84%. And then we give the estimates of that population impacted by 2 feet of total water level and 7 feet of total water level, and by the 100-year flood event and the 500-year flood event. And so with this, it continues on, and we also have links. You can go directly to those maps and Flood Mapper where it brings up that socioeconomic data in those flood levels. The next category is based on household composition and disability. So we have data on people age 65 and over, people age 17 and younger, civilians with a disability. We also have data on single parent households and the impacts from the flooding impacts. The next section is on minority status and language. So we have breakout by minority status and race, people who've indicated they don't speak English well. Then the next section is housing and transportation, where we have data on multi-unit structures, mobile homes, crowding, which is a measure that census provides where there are fewer rooms within a household than there are household members. And then also households with no vehicle. And then also data on group quarters. And then we also have links to all of our other social vulnerability data, so you can open it directly in Flood Mapper and access it and use it within the tool. And then as normal, we have the data sources and the explanation of total water levels there for you. So those are our municipal snapshots. I'll take some quick questions about the municipal snapshots tool before we move on to our last tool, if there are any.
I don't see any. I think Supriya's question was answered. If anyone else has a question, we'll give you 3 seconds to unmute.
Hearing none, I will move on.
Going.
I know I'm throwing a lot of you guys. There's a lot of tools and a lot of information here, so I appreciate you sticking around this. When we do the activity in a little bit, it'll give you an opportunity to really get more hands-on, and we'll be available to answer more questions you guys may have as you start using them. So the final tool I'll show you, this is a new tool that we've just started releasing in the last couple of weeks. This was done as part of a project with the Office of Emergency Management here in New Jersey to help with hazard mitigation planning at both the municipal and the county level. This provides data sets that those municipalities and counties can directly use to do analysis on the potential impacts of hazards, specifically climate type hazards that we have data for in their plans. So it works a little similar to the snapshots where you can select the area of interest, except it's a little more broadly defined. You could actually basically grab data entirely for the whole state, statewide if you want. You can actually get data for a specific county, for some countywide data if that's what's interesting to you, or you can drill down even further into a specific municipality if that's what you're interested in. We'll stick at countywide data so we can see a little more information, since some of these data sets are a little more constrained once you get down to the local level. The first data set we have is a flood hazard analysis. This was specifically done looking at what have been identified as lifeline sectors by the U.S. Department of Homeland Security. So these data sets, we get them directly from Homeland Security, and we already done all the analysis necessary to look at the impacts on various levels of total water level. So I think we have 2, 3, 5, and 7 feet of total water level impact on all these facilities that are within each of these lifeline sectors, as well as the impacts of the FEMA flood zones as well. And so this is a useful way to basically understand what lifeline sector locations exist within your locality, and then automatically what are their potential flood impacts. So the data is initially available in a CSV format that you can download. All the data has lat long coordinates available, so if you do want to map the data, you can easily import that data and map it yourself. We have metadata that explains all the different lifeline sectors and all the information contained within them. And then we also have links to maps of that data that will take you to Flood Mapper with that data automatically loaded. So we can say, look at communications. It automatically selected our locality, so Atlantic County, and you'll see here it's added all the different subsectors within that lifeline sector report into this tool array. So in this case, for communication, it has everything from TV digital station transmitters, cell phone tower transmitters, FM AM transmitters, and different types of antenna infrastructure and communication infrastructure within that county and state. And again, they're all interactive. So you can select a specific location and find out exactly what, in this case, what private transmission tower that is. But we have them for, like I said, communications, energy, financial sector, food, water, and shelter, hazardous materials locations, health, safety and security, and transportation. And so, like I said, the metadata documents are available. They provide links to all the data, explanations of all of them, and when those data were last updated within the Department of Homeland Security that we have access to. And so it's a nice, easy way to get broad impacts and use in your planning for your locality. The second subset of this tool that we added is a heat hazard analysis. And so this is a two-part kind of data set that we've provided here. The first one is county level data on heat waves. So I'm going to open this real quick so we can see that. It's bigger. And so when you download this, it comes in a spreadsheet format. It'll be collected for you. Even if you pick a municipality, provide it at the county that municipality is within level. But you can also get it statewide and provide the data for all the counties within the state. Basically, what we have here is we have the historical data and then projected data for under both a moderate and a high emission scenario out between 2036 to 2065, and then from 2070 to 2099. And so the first column here, you'll see it provides a threshold temperature. So this is the threshold to indicate when a heat wave has occurred. So historically, we were using 81.3 degrees Fahrenheit as our threshold. And then for historically, it shows what the annual mean or average heat wave number was. So in this case, for Atlantic County, we had an average of 1.1 heat waves per year. And then as you scroll over to the right here, you also see there's the annual heat wave duration. And so this says, okay, and those on average, those heat waves last about 3.4 days. And then also the maximum heat wave duration that occurs during that time period. In this case, it was 6.4 days. And then you'll see for the scenarios, basically provides the same information, and also a little bit of extra. So we can see the increases in the average number of heat waves under those different scenarios. We also have the 10% and the 90% heat wave numbers. So this kind of provides you a bound of the most likely range that those heat waves would occur within. You can use that to help understand the potential range for that data. Same thing with the annual heat wave duration. So we can see the increase in the duration of heat waves due to climate change, the ranges for those, the max duration change over time, and again, the range for those as well. So again, this can be useful information when thinking about the potential impacts of heat on your communities. And like I said, specifically when we talk about like health impacts and public health impacts, things like that. The second data set that we have a full metadata document here that explains the methodology that went into get to calculating those numbers and where it came from. So you're welcome to review that and look at that more in depth if you want. The second data set we have is a heat island analysis that was performed and was actually also integrated with the NJADAPT's overburden communities to help understand potential areas where there may be the potential for heat island effect and then where those populations may be most vulnerable to that. So this comes as both a CSV file, which has all the data at a census block group level that can be then linked and mapped yourself if you want, but we also have it mapped directly within a JFlood mapper, and I'm actually going to open that because it makes it a little easier to explain the data. So let's open up our legend here. So you'll see here, there's actually, it's a combination of two data sets. The hatch marked areas here are the census block groups that that has been identified as being overburdened communities based on the environmental justice law that was passed. And then the color coding is basically providing a indication of the ratio of the amount of canopy cover from trees to the amount of impervious cover surface within a census block group. So it's basically provided as an index. So as you get to the dark brown colors to -1, you'll see that means there's a much larger proportion of impervious cover than tree canopy cover within those areas. And the darker green areas are areas where there's a much higher percentage of canopy cover than impervious cover. And so this is basically a kind of a proxy to understand where potential heat island effects may occur. As areas we have a much more impervious cover versus canopy cover, where you can have that radiating effect from heat that can cause public health impacts. And again, all the data is interactive, so you can click on specific census block group and you can get the information on both the, oops, there we go. You can get the information on the actual canopy cover area, the average, the impervious cover for that area. And then you can also get the information for the overburden community data and see the information for that as well. Return back to OEM. The last thing is our social vulnerability data. Basically, we provided the ability to basically get the estimates for the social vulnerability impacts, same as the social vulnerability report we looked at, so the flood impacts on those vulnerable populations at whatever municipality, county, or statewide level you want. And basically, you can download all that data, tabular formats. You can look at specific, block groups or areas within those locations and how they'd be impacted. And then we also have the links to the maps as well, so you can easily bring up, socioeconomic impacts. And so we can look at Atlantic County. Let's take a little time to load here. And we can see it has the overall social vulnerability index for that socioeconomic, and then all the individual factors that you can turn on and off, and look at all of those individually. And again, click on any of them and get the information for that specific location. So that kind of covers the OEM hazard mitigation. This tool is kind of under continuous development. OEM has been very generous in providing us funding to continue to basically add additional data sets to this in the future. So as you'll continue to use this, we'll be providing more data sets that may be useful in that hazard mitigation planning aspect.
Lucas, you had one question in the
Sure.
chat from Allison. Hi, Allison. Are counties or communities able to update their lifelines?
So the Lifeline data is maintained by the Department of Homeland Security. They do the collection process through the state level, and I'm assuming that then trickles down to the local levels as well. That process is not always perfect. We have done some cleanup of the data on our side to make sure that locations that they say are in New Jersey are actually in New Jersey, for instance. Sometimes there are some data error issues because they are compiling this data nationally, but that is handled by the Department of Homeland Security. So. But similar, like we talked about previously, if you have your own data sets that you think are more up to date, you can use that external data tool to then hopefully pull that data in to NJ Flood Mapper to look at that individually. And
Lucas, this next question gets to, I don't know if you wanted to talk about other tools that are under development, but for Supriya asks about, the fact that we don't have this right now as a place you can go to on our landing page. Do you want to speak to that?
Yeah, sorry. So we will be adding that to our landing page. Like I said, we just literally released the tool within the last week or two to do some reporting with and to do some presentations with some groups. So we haven't had the chance to basically add it to our landing page. It'll be there. I'm assuming, Marjorie, within the next week or two, we can work with John to get that up.
Right. And you guys are going to be getting an interactive exercise, which will give you a direct link to it anyway. So you will have it.
Yes, you will have the link to access that as well. Yes.
Yes. Any other questions on this for Lucas? Megan asks, if heat island calculations are only using impervious cover and tree canopy, should localities with mitigating cooling by proximity to water bodies factor that into their planning, or is that not enough of a mitigating factor? And I don't know if you want to take that, or if maybe James, you want to take that.
If James has some input into that, I would appreciate it. So we have discussed that. It's something that's difficult to measure.
Yes, urban heat islands are very hard to adequately measure. Typically, we just use the surface temperature. So that's what Lucas is showing with doing that impervious surface cover to canopy cover. It's approximating kind of surface temperature. But if you're out on the coast and you have some nice onshore winds, that kind of mitigates that to some degree. So it is something that if you're in a coastal community, you'd want to take into consideration. It doesn't mean you can't have an urban heat island, but it may be mitigating that to some degree.
Yeah. And this is a data set that it's a new data set we've created, and we're looking to continually improve it over time. So that's something we can maybe try and work in as we find new data sets that allow us to incorporate that.
Great. Lucas, anybody else have a question for Luke? Well, you came in under time. Great job.
The one thing I will just take a second to show everyone, this is going to be
Yes.
coming out shortly. We are working on a climate dashboard interface to kind of provide some high level information about different types of climate impacts in New Jersey. It's broad at a state level and basically provides you the ability to look at things such as, average precipitation, changes in temperature, those heating and cooling degree days, and mean growing degree days, and basically look at trends over time, what's expected under different scenarios and time frames. So you can switch between like a high emission scenario. If we look at, say, maximum daily temperature and look at different time ranges, you can see how those are impacted under different scenarios. You can look at, different seasons. And then we're also incorporating maps to kind of show changes in that data as well. So this is currently under development. It will be hopefully released soon. We're just kind of doing some final edits and changes on it, but it's something we'll be adding to our landing page as well as soon as it's ready.
Okay, great. So I think we're going to take a quick 5-minute